Okay. Uh, Hello, everyone. Good morning. Welcome back to the fifth session for upgrad course. Hope all of you are doing fine. Yeah, let me just share my screen. Okay. Okay. Thanks. Okay. Okay. Everybody can see my screen? Okay. Uh, Let us start. So today we are going to discuss uh, one more prompting API, okay, structured outputs and LLM evaluations. Okay, so just to recall, okay, in the last class, we had first discussed the LLM decoding mechanisms and parameters. Okay, we had, of course, discussed the different LLMs and what each of these LLMs achieve. Okay, and then we had discussed a bit of uh, function calling, right? So we had discussed these things. Okay. Okay. So, and also we had discussed importantly the OpenAI API. Okay. So we had discussed the OpenAI API, which is used to call the the OpenAI backend servers. Okay. Um, and then you can do you can form a prompt. So we had formed some basic prompts. Okay. And then you can ask the query to the OpenAI server, and it would return you back the response. Okay, so the response is the generated text from the LLM, and this response you get in a string variable in Python, and then you can do whatever you want to do with that. So that was the basic workflow. Okay. Today, we are going to discuss another API, which is the Hugging Face API. Okay. Uh, then we are going to discuss some use cases briefly, and I'm going to tell you some of the plus and the minus of different prompts. Okay. Then we are going to go into structured output, and I'm going to talk about two different things here: constraint decoding, or sometimes also called guided decoding, and then output validation. Okay. And then we are going to discuss LLM evaluations. Okay. How can you evaluate the outputs generated by LLMs for a particular task, etc. Okay, and we are going to discuss two types of evaluation metrics: statistical and semantic metrics, which have been traditionally used by the NLP community, and also we are going to discuss the LLM as a judge technique. Okay. Okay. So let us start with a question. Okay, so this is just to sort of you recall in your mind what was discussed in the last session, right? So when we execute functions using OpenAI's response API using the tools option, where does the function actually gets executed? So Does it get executed on the user's machine? So you are, let's say, running that code on a laptop. So does it get executed on your laptop? Does it get executed on the OpenAI servers? Does it get executed in a combined manner on user's machine and some third-party servers? Could be, okay? Or on a combination of the user's machine and the OpenAI servers. Okay, so I'm going to switch to the Menti tab. Okay, yeah, start responding now. Okay. Let me just go to show responses now. No, this is the previous one. Okay. Okay. Yes. So most of you have gotten it correct actually. Okay. So it depends. So first of all, it doesn't get run on the OpenAI server. Okay. Uh, so sorry. Yeah. Okay. The fourth option is not correct because see what happens on the OpenAI server is that the JSON object, if you remember, the JSON object gets generated which has the parameters to the function call. Okay, so you have to now execute that function call on either your machine, or if let's say the function call involves, let's say, some sort of a third party call, let's say you are calling a search engine or something, then it gets executed on a combination of the user's machine and some other third party call. So what happens in the tools interface, the OpenAI tools interface, is that when you when you send the request to the OpenAI and the request contains the string, the query string, okay, what OpenAI does is it generates an appropriate tool call, and most importantly, it generates the arguments for those tool calls in the JSON format. Okay. So just a refresher for this. Today we are going to do a lot of structured outputs. We are going to see how that actually happens. Okay. But this is an important point, that the function actually gets executed either on the user's machine or on a combination of the user's machine and some other services, third party services that you may use. Okay. I'm not able to. Okay. So now, other than calling these OpenAI servers, there are other ways of running LLMs. In fact, for us, this is probably the preferred way of running LLM. So what is this way? So before going to this, I think most of you have heard about this company called Hugging Face. Okay, so it is a central hub where developers and researchers share and collaborate on AI model. Okay, so what does this company provide? Okay, so it provides a model hub. So if you go to the Hugging Face website, you can see bunch of open source models which have been contributed by various individuals or other companies. So for example, you will see models contributed by Google, by Meta, by Amazon, and also Google, models contributed by various other organizations, like models developed by different universities and so on and so forth. Okay, so basic membership, you can just create an account on this company. It's absolutely free, and you can contribute models absolutely free. Okay, and you can also download those models if they have been made free by the person who has contributed these models. Sometimes they are free, but they are under a so you have to ask for a license or like a key. Okay, okay, so this is the one thing that it provides. Okay, the other thing that they sort of develop and they own is this transformers library. There are other parts of this library, but the main interface that is very popular is this transformers library, which is basically a open source Python library that makes it easy to download and use the pre-trained model. So the model hub contains the pre-trained models, but how do I query those pre-trained models? Obviously, those models per se are not made to run on the Hugging Face servers like in OpenAI. In OpenAI, the models are trained by OpenAI and they are also hosted on OpenAI servers, and then you can just run the models, you can just send in your query to them and you will get back the response. So that is the OpenAI model, and for that they charge you some money. Okay, but for this is the opposite thing. Here the Hugging Face only hosts the model, like it has the model weights, and these are, by the way, fairly large model weights. So I mean, some of the good models would easily be 4-5 GB. Okay, when you try to download them. Okay, so this is their model. Okay, and now that you have this model hosted on their server, how do you run that model? So the primary way using this transformers library is that you have to run the model on your server. Okay, so the library will allow you to download this model and then run your prompt, run this model and run inference through this model through your prompts. Okay, so this is the thing. And of course, it also has this idea of providers. So what these providers do is they do something similar to what OpenAI does. So they take these open source models which are contributed by third party, and they run these open source model on their servers. Okay, so once they run these open source model on their servers, you can send in your queries. Okay, you have to have a authentication token, and then you can send in your queries. Sometimes they are charged. Some of the servers, they allow you a rate limited version of free. So you may be able to send in, let's say, 10 queries per second or something like that, or maybe less than 10 queries per minute or something like that. Okay, and so you send in your queries. I'm using the word queries and queries here. What you really send in is the prompt. Okay, so you send in your prompts and back comes the response. So in that case, you don't have to download the model and then run it on your server. Okay, so we are going to discuss these three ways how you can use Hugging Face API locally on your machine, or either on your server, or nowadays it is also possible to run it on some of the laptops. Okay, then you run it using either this requests API, which is just a way of querying, REST APIs, and or the OpenAI API using the Hugging Face providers and the Hugging Face authentication. There is a third way where you need not use Hugging Face, which is that there are these other model you can say model inference engines like Ollama, then there is VLLM, and there are many others. Okay, there is LLM Studio and so on and so forth. What these engines do is they have their own optimized versions of these open source models. Okay, and what you can do is, instead of programmatically running the, like using the Hugging Face API. So this API basically means that you have to run a Python program to run these models. You can just get these softwares, you can download them. The software can run on your server or on your machine. It can download the open source models, their version of the open source model, not the usual version. Okay, and they can run a query on your local server. So basically, you access them through a HTTP interface which is running on your machine. Okay, so these are the three ways of running open source LLMs. Okay. Okay. So, so these are the steps. First is you install these two packages, Transformers and Hugging Face Hub. Okay. Then this is basically the Python program. So the key thing is you import these two classes, auto tokenizer and auto model for causal language model. Okay, you import this in your Python program. Okay, then you specify the model ID. So I have specified, for example, Gemma 2 billion instruction tuned model. So this IT is for instruction tuning, and this is Gemma 2 billion model. Okay. Next, what I do is I load the tokenizer for this model. Okay, so this tokenizer creates an object. So this is basically a factory function from the auto tokenizer class. Okay, so it creates the tokenizer object, and then basically you can think of the tokenizer as a reference to the tokenizer objects, which is created by this auto tokenizer class. Okay, and similarly you create this auto an instance of this auto model for causal LM class using again the model. So this is basically the model object. So you have two objects. First is the tokenizer object. Okay. Second is the model object in your Python program. Okay. This part you already know. Basically, this is standard torch that you have already learned. So this is setting the device on which the model will execute. Okay. So that is what it is doing. Then we create the inputs. Okay. So the way to create the inputs is we just call this tokenizer object with the query. So here the query is, what is quantum computing? Okay. And basically I am asking it to return the tokens in a PyTorch tensor format. Okay. And then I am moving it to the device that I have selected. Okay. So I have run this code on a Mac. So I am using MPS here. Okay. If you run this code on like NVIDIA GPU, you will use a CUDA here. Okay. So on NVIDIA GPU, you will use a CUDA. Okay. Both of these are pretty fast. Okay. If you if you don't have either, you have a normal laptop which doesn't have a NVIDIA GPU, you normally would use just a CPU here. So you will fall back to CPU. So then the model will run using your CPU on your laptop. Okay. So this is the key idea. Okay. And then what I do here is I use this model.generate function. This is actually calling the model. Okay. This is actually calling the model, and here I am passing inputs to it, and I am passing this max new tokens parameter. Okay. We can also pass the temperature and all those parameters here, what we discussed in the previous case. Okay. And then we get the output. So the output has many things. Okay. But it has the text, but what the output has is the model generated text in tokenized form, because remember, the model doesn't generate words, rather it generates the tokenized text. Okay. So this has the model generated text in the tokenized form. Okay. So what you have to do is, so you have to take this output 0. So there is a possibility for you to actually generate multiple outputs. As you know, if you have a high, let's say, if you have a high temperature, you can, for the same prompt, you can generate multiple different responses, right? So so you can ask, you can set the number of responses, and it will generate more responses. So that's why this outputs is an array. So we just get the 0th element of the output. Okay. And then we decode using the same tokenizer object that we used to encode. Okay. So 3 steps: we encode the input. Okay. So if I were to summarize, encode the input using the tokenizer, generate the output tokens using the model. Okay. And and then finally again decode the generated tokens using using again the same tokenizer object. Okay. Okay. That was the first method. Okay. The second method is, you can simply use Hugging Face's hosted service. So we are using here the request API. You already know the OpenAI API, so I'm going to show you something different. Okay. In the request API, you have to provide the endpoint URL. Okay. So this is the endpoint URL where Hugging Face hosts the hosts the model. So this is basically the URL where you would send in your request. Okay. As you know, the request goes in the JSON format. Okay. Okay. And in the headers, you have to provide your authentication token. Okay. So what happens is, you just create this request post. So this is just a HTTP post. Okay. Which has the API URL, the header where you have the authentication token. Okay. And the JSON, which has this messages array, which we discussed in the same API format. So basically you have the role and then the query. Okay. And the JSON should also have the model that you want to query. So normally the model would simply be if you recall, in case of OpenAI, it will simply be something like the model name. But here you have 2-3 things for the model. First is, this is the organization. Qwen is the organization that is uploading the model. Okay. This is the version of the model. So this is Qwen 3 model and the 32 billion version of it. Okay. And then after colon, you have the name of the provider. Okay. So the provider where you are going to run it. Okay. And then the OpenAI would redirect that request to that provider, and the model would actually run on that provider. So in this case, it is the N-Scale. There are many providers. Hugging Face itself is a provider. Grok is a provider, and there are many other providers. Okay. And then you get the response, and then you can print the various fields of the response. So the response again is very similar to what you get in Hugging Face, right? Okay. The third one is the local model that you run. Okay. So for example, what you can do is, so again on a Mac, you can install this Ollama. There are many other such softwares. You can install any one of them. Okay. And then you can download a particular model. So when you say Ollama run Llama 3, it basically downloads the Llama 3 model to run, and it executes locally. And then what happens is, it provides a web interface or a REST API at this URL, which is the local host. This is the standard port, but you can change the port. Okay, all those facilities are available. Okay, it runs the LLM on your computer. Okay, and basically provides an interface at this API. Okay. So now again you can sort of use this requests API to create a post where you provide a JSON. In the JSON you provide a model. Now here we are using the normal Hugging Face format. So it's, you just have to provide a prompt and that's it. You can also use the OpenAI format. There you will have the messages array where you will have the role and the different thing, right? So you can use either the OpenAI chat completions, or you can use, if you are using OpenAI chat completion, this URL will change. It will be slash like chat completion slash v1 or something like that. Okay. Okay. So these are the 3 ways of running the model. So what is common between these models is, in all these cases, you are running an open source model, right? You are running an open source model. Okay. What this means is that you theoretically, so not theoretically, practically also, you get access to the model weights. Okay. So in fact, you can see the exact model configuration if you are using the let's say this transformers API. You can see the exact model configuration using this model object. So this model object is nothing but a PyTorch model object. Okay. 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 So this is what it is. So here in this slide, I have just explained what I explained earlier in a more in a more direct manner. So basically, it's each step is being explained. So yeah, you can import the libraries. So Torch, as you all know, it's the maths and the tensor engine. Tensors is the model toolkit which is provided by Transformers is the model toolkit that is provided by OpenAI. Okay, name of the model, a string that identifies which AI to download, okay, which AI model to download from Hugging Face. Okay, so actually when you execute this, the model starts to download. Okay, so when you execute this, the vocabulary starts to download. Okay, because you are downloading the tokenizer. So the major component of the tokenizer is actually the model's vocabulary. Vocabulary, remember, is a list of tokens. Okay, and here when you start downloading the model, it actually downloads the model's parameters. Okay, so you will see these two take a lot of time. Okay, this is of course setting the device. Okay, and then this part we have already discussed. Okay, uh, okay, yeah. So this is something we have discussed. If you are running on Apple Silicon, you use MPS. If you are trying to run on NVIDIA GPU, either on your laptop or on a server, you use CUDA. If you are running on the CPU alone, then you use CPU. Okay. Okay. So now you see, you can see the details of the thing working. So how can you see the details of the thing working? So suppose after executing this inputs equal to tokenizer, what is quantum computing, return and basically it returns this tensor. Okay, you can see, you can just print this inputs. If you print this inputs, you will get something like this. So you had sent this particular string, what is quantum computing? It was tokenized like this. So token number 2, token number 1481, and so on and so forth. Okay, so these are the actual token IDs that this particular input string was tokenized into, and you can see it simply by printing this inputs object. Okay. Okay. Similarly, when the outputs get generated, the output is pretty huge. So I'm not showing the whole output, but you can see, you can print the entire output. Okay, and you can see that it is showing all the token IDs. Okay, so these are the token IDs for these the output generated by this. And then you, okay, I don't have the output here, but it would have some sort of output like quantum computing is this, and so on and so forth. So it gives a fairly good description for what is quantum computing. Okay, so you can print the output of it. Okay. Okay. So let me summarize this. Okay, so if I try to summarize this, what, so you have of course a fourth option, which is OpenAI. Okay, so I'm just going to write a fourth option. So today we have discussed three options, and in the previous session we have discussed a fourth option. Okay, which is the OpenAI. Now OpenAI is the simplest. You don't have to do anything. You have to only generate the token. Okay, you have to only generate the token, and you have to pay, and then you can generate the token, and you can just send your request to the OpenAI server, and that's all you need. Okay. The extreme opposite is this transformers thing, which is not only running locally, but you get the full control over what it is running. Okay. So importantly, it will need PyTorch, because PyTorch, remember, is the execution engine for all the deep learning models. I mean, like most of them by default, at least. Okay, deep learning models on a standard hardware. Okay, so it needs PyTorch, and yeah. Okay, and does it need internet? No, not at all. Once you download the, so initially for the first time when it is downloading the model, you will need to be connected to internet. But after that, even if you are disconnected to internet, doesn't matter, you can just run your inferences. Okay. Speed is obviously fast. Important, privacy is very good. Okay. This is a very important point. We will talk more maybe throughout the course, but when you are sending your query to let's say OpenAI, what happens is, suppose you are running an application or your business end. Let's say you are running a chatbot which takes customer complaints and creates some sort of a structured entry. Okay, what was the complaint about, so on and so forth. Okay, let's say that is your application. Okay, so that the customer gives the complaint in plain text. Okay, and you create a structured entry out of it. Okay. What happens is that entire plain text you have to send to the servers of OpenAI, and that means that OpenAI gets the data about your customer. Okay. So that is a big privacy breach, especially let's say if your business relies heavily on the customer data. That customer data, many businesses they don't like to part with the customer data. Okay, they like to store it. Okay. Of course, OpenAI provides it provides a guarantee that the data will not be stored locally and so on and so forth. But nonetheless, the data goes to the OpenAI servers. In these two cases, Transformers and Ollama, it doesn't go to any other server. Okay. Again, for the Hugging Face server, it goes to that server. Okay. So this is an important thing. Okay. Here there is a setup effort. Okay. What I say by setup effort is that you need to install Torch. Okay, that is a huge package. Okay, and you need to download the model weights. Okay, so both these downloads they go into range of gigabytes. Okay, and obviously you have to store that on your disk. So there is a effort involved. Okay. There is a huge model variety here, of course. Okay, thousands of models you can get. Free, yes, you have to provide for the hardware. Okay. What is this best? So it's saying best for research and fine tuning, mainly because for other applications the effort is quite a lot. Okay, but you can also use it for your applications. But if you are trying to run the applications, this is the best thing. So here you don't need Torch, you don't need internet, privacy is full. Okay. Of course, you don't have communication overhead, so communication is fast. Okay. It is relatively easy. The setup effort is relatively easy because all you have to do is you have to download this Ollama package, and then it will sort of take care of everything. Okay, it will take care of downloading the model and so on and so forth. Okay. The model variety is that what they have is they have highly optimized versions of these open source models. Okay. So for example, they do different quantized versions and so on and so forth. Okay. Is it free? Yes. Okay. So it is also free. What is this best for? This is best if you want to use, let's say, very high parameter models, let's say 7 billion, 12 billion, 14 billion, or even 30 billion, or the higher models. Already 30 billion models are very good nowadays. And you want to use them for your business. Okay, that is for that use case, these things are pretty good. Okay, and of course you can use the Hugging Face Inference API. It is basically the same that you do with OpenAI API, except that you have access to these thousands of models, open source models that people have created. Okay. Um, uh, and it is free, but it is rate limited. If you have to increase the rate, you have to pay. Okay. There is a privacy issue, so this is a problem because the data has to be sent to not only to Hugging Face, it has to be actually sent to the providers who are providing the support. Okay. So these are pretty much, these cover the different ways in which you can run this large language models under different conditions. Okay. Okay. So again, let me ask this question. So what is the unique advantage of using the Hugging Face transformer APIs over other APIs? Okay, access to free compute, okay, access to free models, access to open source models with all the inner functioning, okay, uh, ability to run the model on your local machine. Okay, so yeah, so please answer these questions. So think and answer, right? So is it free compute, free model, open source model? Which is the most important thing that you think? Why should you use the transformers API, right? Okay, so let me just see the responses. Okay, so here are the responses. Yeah, so I think this everybody got correct. So access to open source models with all the inner functioning. You can see the tokens, you can see the model architecture, you can see the model weights, you can see the log gates, you can see everything. Okay, so this is pretty good. Okay, and also you can run it, for example, on your own hardware. Okay, or what you can do is, you can, for example, there are these providers like Google Colab or Kaggle or so on and so forth, where you can actually run it on a cloud machine. So it's your code that you are running on the cloud machine. So the cloud is only providing a virtual machine. So there also you can use this transformer model. Suppose you don't have a CUDA enabled server or desktop or something, you can just use those. Okay. Okay. Let us go back. Okay. So now we are going to see some example applications. Okay. So let us see some of these tasks. Okay. Okay. So the first task is text summarization. Okay. So how would you design a prompt for text summarization? Okay. So what would you do? You would first provide the original text in the prompt. Okay. So So this is the original text. Let's say antibiotics are a type of medication used to treat bacterial infections. They work by either killing the bacteria or preventing them from reproducing, and so on and so forth. Okay. And you want to summarize this whole paragraph in one sentence. Okay. So you can simply provide an instruction, explain the above in one sentence. Okay. So remember, so if you are providing a single prompt, let's say you are using this Transformers API and you are just, this Ollama API, this Hugging Face API, and you can simply say prompt equal to a particular string, right? So this whole thing can be your input stream. Okay, so this is your prompt equal to input stream. Okay, and then you ask the LLM to generate, and let's say the LLM generates this particular output. Okay, remember this is different from the role prompting that I told in case of OpenAI. So in case of OpenAI, suppose you want to do the same thing, what would you do? You would say role equal to system, okay, and then content equal to, you would say something like you are an expert summarizer or something like that, right? Expert text summarizer. Something like this, right? You are an expert helpful text summarizer. Then in the role is equal to user, you would put this prompt. Okay. Okay. So this is one example application of text summarization. Okay. Okay. So here is another example application. So let's say there is a big document having the earnings call transcript for a retail investor. Okay. Okay. You want a quick summary of that, right? So you can say summarize the following earning calls transcript for a retail investor. Focus on quarterly revenue growth and forward-looking risks. So you are sort of asking the LLM that you are an executive and you want the summary to focus on something. So earlier you had just asked the LLM to summarize. Now you are also giving additional instruction. You are asking that the summary should focus on particular aspects, okay, because it's a big document, okay, and you are also, let's say, asking it, giving it a sort of soft limit of words. So keep it under 100 words, okay, and the model may generate this kind of a summary, okay. Okay. Here is another thing. So read the provided scientific abstract on CRISPR technology. So CRISPR is this gene editing technology, right? And provide one sentence TLDR for non-scientific audience using simple analogies. Okay. So you want it to summarize, but you also want it to explain to a non-scientific audience. Okay. So this is, let's say, another summarization example where you want a single sentence summary, but for non-scientific audience. Okay. Okay. Another use case can be question answering, right? So what is the question answering use case? So let's say answer the question based on the context below. Keep the answer short and concise. Respond unsure about the answer if you are not sure about the answer. So this is basically the system prompt then. Okay. you first provide the context, then you provide the question, what was QKT3 originally sourced from? Okay, so I guess, yeah, so this talks about some sort of pharmaceutical, okay, and the question is, what was it originally sourced from? So it was originally sourced from mice, okay, as you can see by reading this thing, okay. So here, what you are asking the LLM to do is read this context and then answer this question, okay. um, I don't know if you are seeing a pattern, okay. So the pattern is, first in the system, so this works for many cases, many applications, which is that first you describe the task and describe the role of the LLM in that task using the system prompt, okay. Then you provide it the data. You don't see, for example, another option could be that you put the question first and then the data, okay. That usually gives you a worse answer, okay. So what you should do is you should provide the data, and then in the end you should repeat the question, okay, and possibly you should also, so here not only do you repeat the question, you say answer colon. So you are basically telling the LLM, answer now, directly give your answer to the question now. Don't, don't do any sort of thinking or anything like that, just answer the question, okay. So in the previous cases, summarization cases also, you saw that after you provide the passage that you want to summarize, you say, okay, now summarize. So you provide the final instruction for generating the summary in the end, okay. So this is another sort of takeaway, I would say, okay. Um, Okay, so here is another example. So okay, so so there's a context. The context is that our policy states that employees get $500 a year for professional development. Request must be filed 30 days prior. Okay, and now the question is, can I get reimbursed for a $200 course I bought yesterday without prior approval? Okay. And you want the LLM to answer, obviously no. And maybe generally the LLMs would also give an explanation for this answer. Okay. Again, the system prompt can be that you are a helpful assistant. Please answer the questions based on the current context, or based on the provided context. Okay. Again, so another question answering input, but here now the answer is a bit more constructive. So the prompt is, identify 3 primary constraints of the James Webb Space Telescope mission regarding the cooling mechanism. Format as numbered list. So you see, there is very different. So earlier one was kind of, so it's I'm calling it retrieval. It is basically the traditional question answering setting where there is a context where the answer lies, okay, and now you want to get that answer out of the context. In this particular case, there is also a bit of reasoning going on, but we'll come to that. But there is a lot of retrieval going on here, okay. Here the answer is purely synthesis, okay. So the LLM has to synthesize a long answer, which is a pointwise answer, okay. Okay, yeah. So you can do various kinds of question answering, okay. The third maybe commonly used application is this text classification application, okay. So classify the text into neutral, negative, or positive, okay, and then you actually provide the text, okay, and then you ask the sentiment. Okay, so this is the prompt, and again you can have a system prompt here which says you are an expert sentiment analyzer or something like that. Okay, um, okay. Um, Again, you see the commonality here also. It's a sentiment analysis. Okay, you provide the options of the sentiments, then you you provide the text, and then you provide a prompt, which I have not showed here. So you would have to provide a prompt, something like uh, sentiment colon, and then it will generate this, and it can also generate a reasoning behind this particular sentiment. So you can also provide that in the prompt. Okay, now this is a different kind of text classification. This is like a multi-label classification. Okay, so what is the question? The question is assign relevant tags to this support ticket. Okay, and you provide the text of the support ticket here. So the text is I cannot log in and haven't received my password reset email. Okay, so what are the tags? Okay, so in the prompt you also provide the uh, possible tags. Okay, so it's related to authentication, it's related probably to billing, it's related, is it related to technical, is it urgent? Okay, the user is blocked. Okay, and the LLM may see this text and add these three tags, right? So it's an authentication related issue. It is also a technical issue because there is an email delivery failure, and it is an urgent. So it is not a billing issue. Okay. So in the system prompt, you may provide more clarification that you are an expert who is performing so tagging usually means multi-label classification. So the word tagging usually means multi-label classification. That is for the same. So the difference between this and this is that here the possible tags are positive, neutral, or negative, but only one of them can be true. Okay, for a given input. Here multiple of them can be true, so it can tag with many different tags. So that is the main difference between tagging and the traditional classification. Okay. Okay, then there are things which have come up now much more, like in the past maybe 1 year or so. You can do, for example, code generation. Okay, so you can say write a Python function to calculate a Fibonacci sequence up to n terms using an iterative approach, include basic comments. Okay, and the model may respond something like this. Here it has not actually included comments, but it has responded with the code. Sometimes the code can be wrong and so on. Okay, but increasingly, these are very, very helpful. Okay, the generated code. So yeah. Okay, another thing that has come up again over the last 2-3 years is reasoning, right? So so what you do is you ask the LLM to solve a logical problem step by step by reasoning through the logical steps. So here is an example. Okay, you tell the LLM a farmer needs to cross a river with a fox, a chicken, and a bag of grain. Okay, he can only carry one at a time. If left alone, the fox eats the chicken eats the grain. Okay, how can he cross? Okay, and the model can say, I mean, it will do so. So there are these reasoning models. Okay, many times they will not show the reasoning steps but show the final output. Many times you can also see the reasoning steps. So you can get, so in addition to the output tokens, you sometimes get what are called thinking tokens. Okay. So when you call model.generate, right, you get the output. Okay. And in outputs, there can be output tokens, and there can also be thinking tokens. Okay. And you can access those in the same. See, this output is a JSON which has many different types of tokens. Okay. So this is a JSON which has many different types of tokens. Okay. So the output tokens can be something like this. First, take the chicken across, return alone, take the chicken across, take the fox across, and the chicken back. So it has basically thought through the process that what happens if I first take the fox across. So the thinking tokens would be generated like that. If I take the fox across, then the chicken will start to eat the grain. If I take the grain across, then the fox will try to eat the chicken. So I must take the chicken across. The fox will not eat the grain. Okay, that is why take the chicken across first. Okay, and so on and so forth. Okay. Okay. Then you can do mathematical reasoning. Okay. So Sally has 3 brothers. Each brother has 2 sisters. How many sisters does Sally have? Think step by step. So the model can generate this kind of a logic. Okay. Sally is a girl. Each brother has 2 sisters. Since Sally is one of the sister, there must be one other sister. Therefore, Sally has 1 sister. Okay. Okay. So these are some of the applications that we discussed. And first, let me ask you this question. So, which of the following tasks is not suitable to be performed by prompting LLMs? Okay. Classifying resumes of individuals into different skill sets. Okay. Forecasting stock prices. Generating a summary of US-Iran war updates. Okay. Creating a resume for a job application. Okay. Okay. So please start responding. Okay. So I think we can go to the responses. Yeah. So you've got the hang of it. Very good. Yeah. So so obviously you can use the classification for classifying resumes of individuals into different skill sets. So you can just provide the resume as an input, and you can say you have a list of skill sets, and then you can say you can do a tagging, right? You can tag different. You can ask the LLM to tag different skill sets to a particular resume. Okay. Similarly, you can of course create a summary. So you can take a news article or a bunch of news articles, you can concatenate them, and you can ask the LLM, okay, summarize the for me in one sentence the updates of US Iran war, maybe what has happened in past 24 hours or something, and it will create a point wise summary of the same thing, right? You can ask an LLM to create a resume for a job. Okay, this is probably more difficult than you would think. Okay, you have to provide a lot of input about yourself. Okay, maybe you have to provide your degrees, the projects you have done, your experience, and so on and so forth, and then it will be able to create a well formatted resume. Usually the smaller LLMs are not very good at doing this. You have to go to some of the like Claude or GPT kind of LLMs for generating the resume. But definitely forecasting stock prices, this is actually not very well done by the resume, by the LLM. What you can ask the LLM to do is you can ask it to extract the information that is relevant for forecasting stock prices. So you can ask the LLM to go on the internet, or you can provide, let's say, documents, recent news articles related to a particular company, and then the LLM can say, okay, these are the relevant informations. But then how would the stock price change? That's a time series forecasting problem. So this information can then be fed to a time series forecasting model, which would probably do a better job of forecasting. Okay, so we are, I think, done with the first part. So before we go into structured output, can we take some questions? Do we have questions? Stop sharing. Okay. Okay, I have stopped sharing. No, we are taking some questions and then uh, yes, it is visible. You can go full screen. Okay. Okay. Uh, are we okay? So let me just read out the question. So Kamal Hassan is saying in tokenizer creation code, uh, we are sending model name. Why is this? Okay. Uh, so in the tokenizer creation code, see, the model name is actually close it. So the model name is actually yeah. Okay. So every model has its own tokenizer. Please try to understand this. The way the model gets built is, first it has a vocabulary which can be used to tokenize the inputs test. Okay, this particular vocabulary actually tells you, for example, how many token embeddings will be there, because the number of token embeddings will be the number of tokens that is there in a model. So GPT may have, let's say, a certain, let's say 2 million tokens. Claude may have 3 million tokens. Okay, there may be your another model may have a different number of tokens, and sometimes what happens is models are also fine tuned for different domains. So, for example, there is a medical llama model, okay, which is a llama model, but it has its vocabulary has been expanded to include all the medical terms. Okay, and then this model was retrained to actually generate text over medical documents also. Okay, so that is why the tokenizer is model specific. It is not like the tokenizer is separate. Okay, next question. Or okay, I think it is the same question. Yes. So for each model, the vocabulary is different. If we use the same model using all these three approach and the same prompt, will we get the same output? Okay, this is a good question. So the answer is it's a bit nuanced. Okay, so if you use the Ollama approach, usually people have observed. So what Ollama does, or many of these things do, is they try to optimize. So one of their positive points is that they optimize the model execution. Okay, which also means they sometimes quantize the weights. Okay, usually they don't quantize much the activations, but I mean, they may quantize it. They may quantize it a little bit. They have a different encoding scheme for the activation. Okay, but for this reason, generally these Ollama and all, they tend to get a bit, I would say, you can think of it as lower quality output. But for many practical applications, they try to ensure that this degradation of performance is not noticeable. Okay, only when you go into some sort of a research or something and you actually compare the models, then you see that there is a slight degradation in the performance. Generally, the hosted service and the transformer that you are running locally should produce exactly the same output. Yeah. Only thing is, in the hosted service, only a subset of the models are usually available.
Thank you, sir. Sir,
I hope that answers. So we can go to the next question.
am I audible, sir?
Okay. How is it different in simply asking for a summary and defining a role? Okay, is there is some sort of a question? Okay. Okay, maybe if you have some questions, we can also take them maybe in the end of the session in question answering session, because I'm seeing some questions in the chat. Okay, but how different is it? How is it different in simply asking for a summary and defining the role to the LLM as an expert summarizer? Okay. So what happens is, see, the LLM, at the end of the day, it has been instruction tuned and it has been aligned for some things. Okay. If you, so the LLM is a very general machine, right? So it can generate, for example, outputs regarding yes, okay. So it can generate outputs about, let's say, music, about sports, about politics, about anything. Okay. And also there are many different types of tasks that can be given to it, as I told. So when at the very beginning you are in the system prompt, you are mentioning that the LLM is an expert summarizer. Okay. The distribution, the conditional distribution based on that context of the tokens that will be generated afterwards, okay, have already been set to this summarizer task. Okay. At that point in time, when it is, going through the context and then the question, it already knows that it has to do the summarization. So that is why that setting the role initially in the LLM, that helps the output. Okay. Next question maybe. If I run my code using Ollama Logger, do I risk data privacy? Okay. If you run it using Ollama or local transformer in Google Colab, no, you don't risk data privacy, right? Because Ollama is running on your machine or on your server, or you are using transformer on Google Colab. All the processing that is happening, the code is in your control. Okay. you are not sending, for example, the customer data to something where the code is not in your control. Now you will say, sir, how is the code in my control? It's using the transformer library, but the transformer library is a open source library. Okay, so people know that if transformer library was in the middle somewhere contacting another server and sending your data there, people would have discovered that. Okay, so short answer, yes, there is no privacy risk if you use Ollama or you use the transformer in Google Colab. Okay, so thanks everyone. So we will maybe take a break and come back in like 5 minutes. Okay, so we are I hope my screen is visible. We are going to the so we are starting to discuss the structured output generation topic. Okay. 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 So what is the problem? The problem we have, I think, already described. Okay. So your LLMs can generate unstructured text. Okay. Your LLMs can generate free form unstructured text. Okay. Uh, so the question is, can it generate text in a particular format? So what can be particular format? So for example, suppose I want the LLM to only generate a valid URL. Okay, a very common feature that I want the LLM to generate a valid URL. Okay, another maybe very common use case that we have already discussed is I want the LLM to generate a JSON. See, the response, I mean, you have to understand, this is not the same as the outputs. So there is the output response variable, which is generated by the LLM. Okay. That is already in JSON format. Okay. But let's say in output, there will be some dot messages or something like that, right? When you decode the exact field, you can just look it up. And it depends on the API. In OpenAI API, I think it is output 0 dot response or something like that. Okay. But the main thing is that that is already a structured Python object. Okay. That is not what we are talking about. What we are talking about is when you decode the tokens, okay, there is a text that is generated. This text should be, let's say, a formatted JSON output. Okay. Uh, you can, maybe you want to generate custom schemas like dates, phone numbers, order IDs, etc. Okay. Uh, you want them to follow a particular regular expression. Okay. So you may want this kind of a constraint generation. Okay. You may want constraint generation based on a grammar. So either it can be DFA, or it can be like it can be a context-free grammar. Okay, but you want to generate the output using a certain grammar. Okay, these are some of the situations, or these are some of the use cases where you want to do constraint generation. Okay. Okay. So just go back to the generation step 1. So how does generation step work? So suppose you have a prompt. Prompt is nothing but the context of the sequence. Okay. So you have a prompt, and step by step, so autoregressive decoding, what you do is you generate different tokens step by step. So maybe you generate in step 1 the token corresponding to 16, and then 32, and so on and so forth. Okay. So how this works? The way it works is, at each step you go over the entire vocabulary. Okay. So at this step, and for the entire vocabulary, each token has a certain output probability. Okay. And the 16 got generated here because the probability corresponding to the token 16 was the highest. There were other tokens in the competition, so 32 was also there, and then all these things were there, but this was the highest. Sometimes you do a sampling also. Okay, so that is the token by token autorecursive decoding. Okay. Okay, so this is saying the same things we have already discussed. You calculate the logits, you do the multinomial probability distribution using the softmax over the logits, and then you go ahead. Okay. Now, additionally, what I told is that you can do something like a masking. Okay, so how can you do, or what kind of masking can you do? Okay, so what you can do, let's say these are your tokens. Okay, you have 9 tokens out of which you generate some. Okay, and let's say this is the probability distribution, right? So this is the probability distribution over all of this. So this is the logits, and using the logits you can also construct the probability distribution, and then you do some sort of a top k. So these brown ones are now the ones that are selected. So let's say you have done a top 4 or something. Okay, and then what you are doing is you are uh, uh, you are okay. What you are doing is you are sampling from these brown ones here. Okay, so okay, so this is the standard the temperature based probabilistic sampling that we do. Okay, after doing a top k, or you can do a top p. We have discussed this. Okay, now what you can do before you generate the probability distribution from the logit, after you have done the top k, what you can do is you can do another masking. What do you do? So you say, for example, that in this particular step, odd numbers will not be generated. So what do? You set the logits of the odd tokens to -infinity. Remember, logits are some number between basically -infinity to +infinity. Generally, they are negative because they are log probability. They may not be negative. Okay, so they can also be positive. And then what you do is you generate e to the power logit of I by summation e to the power logit of j, summation over j, and this is the probability of token I, right? This is the softmax distribution. Okay, so when you do the masking, that is, you make the logits for certain tokens, in this particular case the odd tokens, -infinity, what happens is e to the power -infinity is basically 0. So their probability of sampling becomes 0. Okay, in the original logit distribution that was given by the LLM, these tokens had a finite logit, and hence they would have had a finite probability. In fact, for example, this 7 actually was the winning probability. Okay, but now you are using this masking rule where you are saying, in this particular step, I will not generate odd digits anymore. Okay, if that is the case, then what happens is that you basically get this kind of a logit distribution. Now you calculate the sampling distribution for these two, which are the surviving ones, and then you sample from that. Okay, so here actually this will be actually there will be the temperature here, logit by the temperature, because you will use the temperature sampling. Okay. Okay, so this is the key idea about the masking mechanism. Okay, so in addition, so this is what you change when you want to do a constraint decoding. You constrain the token generation by masking certain tokens out. Okay. Okay. So now the question will come, how did I choose that I will mask out those odd tokens? Okay. So how will you choose what to mask out? You have to have a rule for that, right? You have to have a rule. It's a logic. It's not a probabilistic thing anymore. It's a logic. So remember, we talked about all these different ideas, right? So we talked about JSON generation, maybe generation of URLs, generation of phone numbers. How are these things defined? They are defined with some sort of a rule, okay? Maybe a regular expression rule or something, some such rule. Okay, so for example, this is a rule, right? So odd numbers are allowed only at the start of a sequence or after an even number. So one odd number cannot follow another odd number. So this particular sequence is invalid, this is invalid, this is invalid, this is invalid. These are all valid sequences. Okay. So what would generating in each step involve, right? So you see, if so this is kind of then the valid invalid mask, right? So if you start in the beginning, okay, everything is valid. After 1, only 0, 2, 4, 6 and 8 are valid. Okay. So at the time of, because it's a autoregressive decoding, every time step it is decoding one after the other, what will happen is that it will immediately, when it sees that it has generated a 1 in the previous time step, it will mask out all these tokens. Okay. Similarly, it will mask out these guys if it has generated 3 and so on and so forth. Okay. So that is how the mask is generated. So there is a rule. From that rule, at a given time step, the mask is generated. Once the token is generated, the mask has to be recalculated for the next time step. Okay. Okay. So what will you do? So okay. So this is the simple thing. So this is something that I have already told. So what is the bridge between the text and the token IDs? That's the tokenizer, right? Okay. So that is the bridge. Okay. Now let us go to this logits processor or this logits mask class. Okay. So what you need to use in order to implement this masking mechanism, so you can use many things, but one of the things that you can use in the transformer library that we discussed is this logits processor class. Okay. So what you do, so this logits processor class, what is it? It is basically a callback class. Okay. So it's a hook, it's called a hook. Okay. That is called at every generation step. Okay. And what is the input to this hook? The input to this hook is the current input IDs and the scores. Okay. And what is the output? The output is basically the modified scores. Okay. Okay. So this is the class. So when you want to implement a particular rule, you have to implement a class. Okay. Okay. So let us say, so here we are showing the implementation of this logits mask class. So what does this logit mask class do? It basically has a list of allowed token IDs. Okay. So you are allowing some token IDs at each let's say time step. Okay, these allowed token IDs will only be allowed and then it will recalculate the scores. Okay, so what does it do? Obviously, in the init, it just sets the allowed token IDs. So you provide it the allowed token IDs. Okay, and then in the call step, what you do is you get the input IDs and the corresponding scores. Okay, and then what you are doing, you are simply doing the following. Okay, you are setting this mask, and instead of setting minus infinity, you are just multiplying it with minus 10. Okay, you are not because minus infinity can cause problems. So instead of setting it minus infinity, you are setting it uh, to minus 10. Okay, you can also set to minus infinity, by the way. Only thing is it will drive the probability to exactly 0, and then it may happen that at a particular step all your token probabilities become 0. So then there will be a problem. Okay. Uh, okay. So a priori you are setting the mask to minus 10 for all of them. Okay. Then what you are doing is you are, for the allowed tokens, you are setting the mask to 0. So initially all of them are minus 10. Now you are setting all of them to 0. Okay. Then you are basically doing scores is equal to scores plus mask. Okay. Why is this? Why is this happening? This is happening because remember, your probability will be something like e to the power scores, right? By the normalizing factor. Okay. So your new scores, let me just write here, your new scores is what? Your new scores is scores plus mask. Okay. So into in the exponential domain, what happens? It is e to the power scores times e to the power mask. What is mask? Mask is minus 10. So for the disallowed tokens, the e to the power scores get multiplied by e to the power minus 10. For the allowed tokens, it gets multiplied by e to the power 0. Okay, e to the power 0 is 1. E to the power minus 10 is a very small positive value. Okay, so I hope you can understand why this setting makes sense. Okay. Okay, so this will effectively mask out the tokens that are not there in this allowed token list. Okay, so in the main code, what will you do? So for example, let's say you are generating phone numbers. So you are only allowing these tokens. Okay, so you can say, you can generate allowed token IDs as, you basically for every token, every T in this list. So list is basically all the digits. So 0 to 9 and then space. Okay. For all of these, you use the tokenizer to encode. What does it do? It basically gets the token IDs. Okay. And this is important because many a times the tokenizer, what it does is it gives the it generates this opening. There is this special token called 2 which it generates, which is the opening sentence token. So you can just use this hack. Okay. Okay. Okay, so these are of course allowed tokens, and you also allow the end of sentence token, because otherwise your generation will not stop. So you have to allow the end of sentence token. So you create the allowed token IDs like this. Okay. Now when you are processing the generate call, right? When you are processing the generate call, you set up the hook. How do you set up the hook? You say logits processor is equal to logits mask allowed token IDs. Okay, so it basically creates this logits mask object with the calculated allowed token IDs. Okay. Okay. So if this is the case, so I am just showing one code here. Okay. So you see, you create this logits mask object. An instance of this object will be used for masking the tokens. Okay. I have created this, I have explained this is how you create the allowed tokens. Okay. Then what you do is, in the generate call, you do the generate call with the logits processor hook set to an object of this logit mask type. Okay, you generate the output. Okay, so basically what I have done here is, first I have generated the output using the hook, which is this, and this is the second call where I have generated the output without using this hook. Okay, and the context that I am providing here is, what is the context? The context is same. Yeah, a list of colors. Okay, so this is the context. Okay, so if I don't use the hooks, it gives a list of colors like this, primary colors, red, yellow, and all this, which is the second call. So this call leads to this output. The first call, where I am using the hook, that leads to this output, 10000000. So what is happening? Every time it is basically generating that. So first time, I mean, it is only sticking to the numbers. First time the number with the highest probability was 1, and then subsequently every time the number with the highest probability or the decoded number was 0. Okay, that is why it generated this output. Okay, so this is how, I mean, this is one of the ways of constraint. So this is called constraint decoding. Okay, constraint decoding. Okay, okay. So for example, here is another example. So now, so in the previous example, it was very simple. There was a list of a static list of tokens which were debarred every time, right? This time, what we want is, we want so we want a list of tokens that satisfies a regular expression. Okay, so instead of a fixed allow list, we test at each step whether appending each vocabulary token keeps the output consistent with a regex. Okay, so for example, suppose your regex is something like, you have to have HTTP colon and then let's say dot some, let's say some characters. So so let's say \C plus, okay, and then .com, right? So then suppose I give it HTTP already, okay, and I give it to the regex processor. At the next time step, the regex processor will only allow the colon token to be generated. Okay, the regex processor will not allow any other token to be generated. Okay, so how does this work? Okay, so you are using now, you are creating now a regex mask. Okay, so as an input, you take a regex pattern, and here basically we are using the Python package called regex. Okay, which basically one of the things it does is it allows this partial match to a particular regular expression. Okay, so you take in a regular expression token. Okay, okay, of course you store the tokenizer. Okay, uh, you have the vocabulary map and so on and so forth. Okay, now this call function is the hook that is called every time the decoding happens. So let us see what it is doing. So what it does is okay, so every time you get this input IDs are so input IDs have the tokens from 0 to like start index, right? Sorry, from start index to the current, right, to the end. Okay, okay. So those, that gives you the partial string now. Okay, now which all tokens should be allowed? Okay, so what you do is of course EOS token is allowed. Okay, so you are building the allowed tokens here. Okay, EOS token is allowed. Okay, then you get the token ID and the token string for each of the vocabulary. So that's why you get this vocabulary map. So you pre-compute the vocabulary map so that you don't have to decode the vocabulary map every time. Okay, now what you do is, to this partial, so partial thing is itself the decoded input that is there in your current. So basically in this HTTP scenario, HTTP is this is the partial thing. Okay, so this is the partial. Okay, now you try out all the token strs over the vocabulary. So it will try out all the other ABCD, and also it will try out this colon, let's say. Okay, and if this regex match is true, okay, so it will send this whole thing HTTP colon to the regex match. Now this will match while other things will not match. Okay, so for only this statement will turn out to be true. So it will append the corresponding token ID which you have got here to the allowed list. Okay, okay. And then of course from the mask you subtract so for the entire score array you subtract everything. Okay, and then you that is the mask. This was set to -10 last time. Okay, right now we are setting it to this subtract value. Okay, that could be that could be 10, for example. Okay, and then for the allowed guys we set the mask to 0, and then the same logic as last time. Okay, so so this is the basically your regular expression mask. The important thing to note here is that you have to set this partial match to true, because your regular expression, the full regular expression may not match. So it should be able to match a prefix. Okay, okay. So this is the idea. Yeah, so that is the idea that we are setting here, that basically this is a property of this regex package. Okay, so if you compile this kind, so this is a particular regular expression, as you can see. Okay, If you compile this kind of a regular expression, okay, and then if you send http://test dot, uh, it will say none because uh, it should complete something like .com or something like that. So it is saying www dot a word slash dot a word of length 1 to 6, something like this. Okay. Okay. But if you set a partial match, then this is actually true. Okay. So that is the key idea about this. Okay. 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 So, and then if you use it, so for example, uh, you send to an LLM a query like one of the most common web addresses is, okay? That is the query, and then you want it to generate. The LLM may generate www.google.com, which is, you know, as a human being also we would generate this, but this is actually not the URL. The URL is this, okay? So if you provide this this regex mask with this particular hook, then it will maybe generate this kind of a output, okay? Okay, yeah, and also no trailing prose. So it may, after generating this, it may not stop. It may generate some more text. This is a well-known and widely used search engine and so on and so forth. Okay, so with that constraint decoding, you are also basically stopping that. So first of all, it is putting this, and it is also stopping the generation of the trailing text. Okay. That is the advantage. So you can directly use this string in your application now. Okay. Uh, okay. And basically, all the other things are valid. So, for example, if you set, so it works in the same multinomial sampling framework, right? So, if you, let's say, increase the temperature a little bit, okay, maybe it is generating many domains, okay, which is good, okay. It may generate many domains, but all of them are correctly formatted domains, okay. Um okay. Uh, okay, so we take a break, and not take a break, but we take a question. So the question is, which of the following is not enforced by logits processors? Okay, only allowed tokens are generated. Some of the allowed tokens are generated preferentially. The output follows the input grammar completely. Partial matches from nested grammars. So here I will tell you what is a nested grammar. Nested grammar is basically something like, let's say I have a regular expression, right? Now inside the regular expression, I may have another, either regular a sub expression, or I may have something that says it should follow another grammar rule. Okay, this may be a date, for example. Okay, and so on and so forth. Okay, so this is the nested grammar. We will see it in like a few minutes. We will see more clearly what is a nested grammar. But so go ahead and try to answer this question. Let us see. Huh? Okay, please respond to this. Okay, just to be clear, so I think the fourth option is clear, whether nested grammars are allowed or not. The third option is whether the output is actually checking for a particular grammar completely, right? Uh, yeah, uh, yeah. Here, is it that you can use this kind of a logits processor class to or rather subclass, logits processor subclass, the hook basically, to uh, uh, allow some tokens to be generated preferentially. Okay, is this feature still allowed or not? Okay, or is it that after applying the mask, all the tokens become equal probability? Okay, uh, and of course, only allowed tokens are generated. Okay, so let us see. So I think many of you have answered. So let us see the responses. Okay, so I think you have got the answers almost correctly. Okay, the main thing is that this completeness is not allowed, right? So if you see, what it is doing is, at every decoding step, it is generating the like it is at every decoding step, it is so it is checking whether the prefix matches or not. So for example, if your thing must end with, let's say it has to be a 10-digit phone number. Okay, when the LLM has generated 5 digits, okay, that is when the logits processor actually starts, right? So at 1 digit, 2 digit, 3 digit, 4 digit. So it is not easy for you to specify that it has to generate actually 10 digits. Okay, so the completeness is not there, but you can specify that it should generate digits. Okay, so that is why this completeness is difficult to specify using this logits processor. Okay, of course, can some of the tokens be allowed to generate preferentially? Actually, yes, preferentially, in the sense that so you can do two things. First of all, you can if you recall. So let me just go to the slides now. If you recall, yeah, you were modifying these scores using the mask, right? So you can write here some sort of a logic that will preferentially allow some digits. Maybe suppose the digit 91 towards the beginning of the phone number, 91 should be generated more, or something like that. That is preferentially generated. I'm just saying some practical thing. So that can be allowed by simply saying, you can put a logic like, okay, so what is the length of this input IDs? So if the length of the input ID is, let's say, less than 2, then give higher preference to 9 and 1, something like that, right? So it can be actually, so you can use this logits processor to modify the scores, and in particular you can modify the scores not just in a masking manner but also in a continuous manner. Okay, so you are allowed to actually generate preferential things. Okay, so so what did we learn? Okay, so okay, so these are, so we have discussed this. So basically, this logits processor has a problem. There is no look ahead. You cannot look forward to see there is completeness. Okay, um, yeah. So how do you, what do you do when you have, let's say, your tokens are many times not digits, right? So how do you go into, let's say, if you have multi-token digits, or you have like, how do you know which tokens are are preferred. So that logic also is somewhat difficult sometimes to provide. Again, state awareness, it has a bit of state awareness because you can see the generated string till now, but it's difficult. You have to implement the logic of state awareness in that call function. Okay, and how do you prohibit? Of course, you do some sort of a soft penalty, but doing hard penalty is generally not recommended. Okay, so what people usually do, like for example, when you go to OpenAI structured decoding, it actually allows, and there are other structured decoding libraries also, which they don't tell exactly what, but they allow you to decode using a grammar. Okay, so for example, you can specify a JSON schema, and they would actually generate a complete JSON object. So for example, if you say an object like let's say role colon some string and then comma and then nothing else, right? So this is a valid prefix of a JSON schema. Okay, but it is, for example, there should be some other, like there should be some other property and then a closing bracket that is not there, right? So so logic processor will still generate this. Okay, but what the structured decoding does is it actually generates the complete thing. Okay, and there are many ways of doing it, and so some of them, they use this DFA, discrete finite automaton, to track the state, and then they wouldn't generate, or they would generate multiple tokens and they would return them only when it has reached an end state. Okay, otherwise it will not return the token. Okay, so that is this thing. Okay, so this here I am just mentioning how like this OpenAI's structured decoding. So in what steps does it work? So the way it works is that when you provide an input, we'll come to the code in a minute, but you provide a schema for the structured output. Okay, for example, you provide a JSON schema or something like that. Okay, as input. So when the underlying LLM generates token, it does what is called a schema constraint token selection. Okay, so at every state it uses some sort of a masking mechanism similar to what we have described to actually do a schema constraint token selection. Okay, then what it does is, of course, it does incremental parsing. So it checks the prefix validity. If the prefix is not valid, it discards that generation, and it does multiple such generations. Okay, then these multiple generations are also then stored or compared to a finite state automaton. Okay, so and then basically they track the state of this schema control generation. Okay, and only when it reaches a self state, an end state, the generation for that particular sequence ends. Okay, so remember, it's a sequential decoding process that goes on. So multiple such processes are done. Okay, so this is at generation time. After that, they do few things which we will also look at next, which is called the output validation. Okay, so what does it do? Output validation. So in output validation, it does something like a type enforcement. So when you provide a schema, you can say that a particular generated field should be of type integer or string. So it will do that type enforcement. So even if it is it will be generated as a string because it's generated as a string of tokens. But then the type enforcement will check that that string can actually be typecast into the actual type. Okay, so this is one form of output validation. Another form of output validation that will be done is this required field tracking. So if there is a required field versus an optional field, it will make sure that the required field has been generated. Otherwise, again, it will not return that and it will go back to generation. Okay, and of course control termination. Okay, so as I said, the generation stops only when the JSON is syntactically complete. So you have the complete this thing. Okay. Okay, so with this, now let us go into the output validation step. Okay, so of course OpenAI does it internally, and we don't know how it exactly does, but there are some open source techniques that you can use for output validation. Okay, so how can you do a output validation? Okay, so let us see. So obviously asking a model. So now we are saying, suppose you are using, let's say, a transformers generate or something like that to actually generate a response. Okay, how can you from your end know that the actual response, actual generated response is a valid JSON response, right? So okay, okay, so how do we do it? So let us go ahead here. Okay, so we use this package called Pydantic. Okay, so Pydantic is a Python package which basically allows you to define these JSON schemas. Okay, so how does it allow you to define the JSON schemas? Of course you can define schemas in many other ways, but what Pydantic does is it provides this base model class. Okay, and you can basically define different Pydantic defined classes by inheriting from this base model class. Okay, so for example, you are now defining a JSON schema, okay, which is of type person. Okay, and it should have two fields. Both fields are required here. The first field is called name. Okay, and it's of type string. The second field is called age and it is of type integer. Okay, so this is a Pydantic based model. Okay, now suppose, so you try to create a Pydantic object. So first of all, it does a object validation. So this is the object validation or output validation part. Okay, so if you try to create a person object, let's say you give name equal to Sam and age equal to within quotes 10. Okay, what it will do, it will create this person object. What is this person object? Name is equal to the string Sam, but age is equal to 10. Okay, now instead of this age is equal to within quotes 10, suppose you gave age is equal to within quotes, let's say 10.5. Okay, that is not an integer. Okay, then it will throw an error here. Okay, it will not create. So that's why it is doing a output validation. Okay, so it will not create this object. It will throw an error here. Okay. Okay, so this is the output validation part, that when you try to create a Pydantic object with a data provided, okay, it will do a type validation and required field validation and all of those. Okay. Secondly, you can just, so now that you have created this class, you can just generate the schema itself using the pydantic model. Okay, how do you generate the schema? So the schema itself has to be generated in this JSON format. Remember, we were describing this JSON format when we were doing tool calling. Okay, so you have to, so when you call this person.model underscore JSON underscore schema, what it does is it generates this property. So it basically says that the JSON should have these properties: name, okay, title is name and type is string, and then age, title is age and type is integer, okay, and then these are the required fields, and then the title of the object is person and type is object, okay. So this is the standard schema format for an object which is also taken as input by, for example, the OpenAI API. Okay. So as you can see, this format is pretty difficult. Okay. Like for a very complicated object, like you are, let's say, trying to asking the LLM to generate a database entry for, let's say, a order that was, let's say, for a food delivery order, right? So the person, let's say, has given, give me one biryani, one this, one that, okay. So what happens is that this order is a very complex object. So it should generate the person's maybe email ID, person's phone number, person's account name, and then it should generate a list of order items and with quantities and so on and so forth, right? Then it should generate address and so on. So this schema thing can become very, very complicated for practical applications, okay? But the software developers, they have been doing this work for a long time. So they actually generate this kind of objects. Let's say you can generate an order object where the sub object is, one is the order person, then the list of order items, and so on and so forth, right? So you can generate easily using this Pydantic, and then you can automatically generate the schema for that. You don't have to manually write the schema. Pydantic will write the schema for you. Okay. Okay. So this is something I have told, that Pydantic actually does a validation. Okay. So for example, so this is the thing, that even if you provide age equal to 10, okay, it will actually be able to convert this 10 to the actual type, which is int. Whereas if you just use a data class and say age equal to within quotes 10, it will basically throw a type error. Okay. 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 So let us go ahead and do so how can we use this whole Pydantic thing to ask for a JSON object from a OpenAI? So okay, so we import Pydantic base model and we import, of course, OpenAI. We create an OpenAI client. Now let's say we are creating this hierarchical Pydantic object. So first is, let's say, a Python package. So a Python package has a name and the author, both are string and both are required. Okay. Now here is a simple thing. What you can do is you can say client.chat.completions.create. So this is basically you are calling the OpenAI API. You are giving it the model. Then in the messages arrays, you are giving it the user role and the prompt. Return the name and author of Pydantic in a JSON object. Okay. Okay. So the output may not be a JSON object. So this is actually you are not okay. So suppose this is the thing. Okay. What do? You expect the response output to be a JSON object. Okay, you try to parse it as a JSON object, but that may fail if the JSON object is not there. So this is the validation. So you say Python package dot model validate JSON, and then of course response dot choice is 0 dot message dot content. So this is the content returned by this particular call. Okay, so this content may not return the JSON object, right? And this particular output validation check will tell you whether it has returned the JSON object or not. If it fails, then the object returned will be a non-object. So it will not return a valid object. Otherwise, it will return a valid object. Okay. So this is the first thing. Okay. Now, as I said, like if you want to actually in the tools array, like in the tools, you are providing this JSON schema that you want the output to be generated in. Okay, this can get pretty complicated. Okay, so using Pydantic, what you can do is you can make it very, very simple. So what will you do? You will create this Python package, and you have created now another class which is the packages, okay, which is actually a list of Python package. So Python package is like the package name and the author, and then you can have a list of Python packages. Let's say this is what you want your JSON object to return. Okay. Now again you do the same thing. You call the model. Okay. And in the messages array, you just give Pydantic and Fast API. These are two like Python packages, right? And in the tools, now you give a function. Okay, the function, you are just calling it requirement, so it doesn't really matter what this function is. Only thing is that you should choose. So what tool choice does here is so basically the GPT generation mechanism, right? It works in two modes. One is that it can generate in tool calling mode, okay, in which case it basically does a structured decoding. Otherwise, it can also choose to not do the tool calling and just generate a normal response, right? So this tool choice actually forces it to generate a structured output. Okay, so that is the purpose of this particular step. Okay. Okay. So, but then what is the tool? So the main thing that, remember, the tool calling generates are the parameters. Okay, and in the tools definition, so this is the tools definition stage, right? You are defining an array of tools here. Okay, in the tools definition step, you simply say packages dot model JSON schema. Okay, so you see you have defined the JSON model. The schema is supposed to be extremely complicated, something like this. But if you remember here, right, it is basically generating this schema all by itself, and basically there is no error. Okay, so you define the Pydantic model, and then in the parameters here you just call this packages, which is the final output that you want. Okay, packages dot model JSON schema, and it will provide the correct JSON schema here. Okay, and then of course when you get the output, you can use packages.validate to actually get the result. So if it has generated the correct response, you will get a correct response here in results, the correct JSON object. Otherwise, what you will get is like a none object. Okay. Okay. So this is what this particular code is doing. Okay. Okay. So here is another thing. So for example, you can have a date range. So start a date time dot date. Okay. So date range has basically two fields, start and end, each of which is of type date. Okay. Then you have a search query, you have a rewritten query which is a string, and then published date range. Okay. A date range and domains to allow list of strings. Okay. And now uh, uh, yeah, so what you are doing is you are basically doing a search for this search query. Okay. So now so so when you provide a search query to it, okay, it creates a JSON output with a rewrite to the query. Okay, so you provide an initial search query. Okay, it basically creates a rewrite query, it creates a date range, and it creates a allowed list. Okay. Okay, so now there is so that is your now new this Pydantic schema. Okay, so what is your schema? Your schema is that you want to have this you want to have the structured output as a search query. Okay, this has complex hierarchy and so on and so forth. Okay. Okay, now here I am describing another tool which is the instructor tool. Okay. Now you can just simply use the Pydantic, but what Pydantic does is it makes it explicit. So you have to explicitly write the API query and then do the post validation. So you have to provide the schema in the API query and you have to do a post validation. Okay. What this instructor does is that it automates this whole thing. Okay. So the instructor automates this whole thing. So what it does is it creates an OpenAI client, but adds a instructor wrapper around that OpenAI client. Okay. So when you are doing the search query, okay, you are obviously providing the query. Okay. Now what it does is it so you have to just say client. Note here client is now not an OpenAI object but an instructor object which has been wrapped around a OpenAI object. Okay. Now this instructor object is basically pass the model just like you would pass to the OpenAI. Then you would pass the response model which is this search query, and then the prompt in the messages. Okay. So yeah, you are a query understanding system, today is the following date. Okay. And then in the user query you provide the input query which has been provided here as a string. Okay. So so this query is same as this query. Okay. And what it does, it forms the schema. So earlier, if you recall, here you had to form the tool, you had to provide the schema, and the output you had to do validation, right? All these things are now done by this. At the end of it, you get the validated output. So if you print now this result, okay, it will be this. Okay. So this the entire structured output will come. Okay. So this is just a wrapper, and this is basically a very clean interface to doing structured output. So all you have to do is you have to define a Pydantic class which is here the search query. Okay. And then in the response model you have to provide that Pydantic class, and the messages as you would provide to the OpenAI, this will be passed exactly to the OpenAI query, and also the model will be passed exactly to the OpenAI query. Okay. 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 Yeah, so some tips for using Pydantic model. You should, I think these are some generic tips which are correct. So you should use very descriptive field names. Okay, you can add a field description, something like this. Okay, so you can say a rewritten query str is equal to field, and then you can have a description, okay, for the LLM to have extra context. Okay, you can of course nest models for clarity. Okay, this is done very, as I told, like you define date time, then you define a date time object so like object oriented programming. Okay, and you can also have optional. Okay, so you can mark fields as optional in Pydantic, and then it would still validate objects which don't have the optional fields. Okay, so that is the idea. Okay, so that is about the structured output. So broadly, two phases of it. One is constraint decoding, where you actually generate the tokens which follow the format. Second is, after you have generated those, you can actually do a post validation. Okay. Okay. So now answer this question: which of the following statements is true? Pydantic is only used for output validation. Okay. Uh, Instructor does the schema validation. Okay. Pydantic can generate and validate schema. Instructor automatically generates the tool calls from Pydantic schema. Okay. No. Yeah. Yeah. Please send your answers now. Okay. Okay. Please, once we cross 100, we can just go to it. I hope this is clear, right? So yeah, like this should be fairly intuitive. Okay. Okay. Uh, 99 and then 100. Okay. Okay. So great. So you guys are understanding. Yeah, both 3 and 4 are actually correct. So Pydantic, I think third option is pretty obvious. Pydantic can generate and validate the schema, and instructor automatically generates the tool calls, as you can see, right? So if you so this is also actually correct. Okay. Um, so uh, as you can see here, like you did not, so when you are using the instructor API, you did not have to actually list the tools. Okay. So the you just provided the Pydantic class, which is where is it? Sorry. Yeah. Yeah. So this is search query is the Pydantic class. So you provided the Pydantic class. Okay. Here you only provided the messages, right? when you provided the messages, it was already like it was but it was doing a tool based decoding. So all of this, the generating the tools array and the tool choice and the schema, all of this was done internally by the instructor. Additionally, it also did the output validation. Okay. So the fourth option is also true. Okay. Uh, so now we stop for some question answers. Uh, Stop share, and then it's okay, right? Okay. If the logit processor are not following the rules completely, then what's the point of having it? Then can't we just write instruction to the LLMs instead? Okay. Uh, okay. See, okay. So this is a good question. Let me clarify this. Okay. Maybe I can, or you can. I can share. I can switch to the slides for this question. Uh, uh, okay. Uh, okay. Uh, yeah. So this it is important to get this right. Okay. Yeah. So consider this, right? So let me. So so consider this example. I think with this example, it will become even more clear. Okay. Remember, so what we are doing here, I'm just removing this. Okay. Consider the two options, right? I have generated here two tool calls. Okay. The first tool call is with the logic processor, where it was generating this output. The other tool call is without the logic processor. Okay. Now, what am I doing? If I were to try and do a output validation, what would I say? I would try to take this string and I would try to say, is this a number, or is this an integer, or is this a list of integers? Okay, something like that. Suppose I don't use the logic processor, it will generate output like this. My validation will fail. Okay. Again, I will make another, either I will make another LLM call, or internally it will make another LLM call. Okay. Whatever it does, okay, you are actually wasting many LLM calls. Understood? So this is very important. Until the LLM actually generates a number, if you only provide in the prompt generate a number, it may generate a number like this, but it may not generate a number also. It may generate, so depending on the prompt. So here the prompt I have given is a list of colors. Before that, let's say I have asked it generate a number, then I have said a list of colors. It may generate a number, may not generate a number. You don't have control over that. Okay. If it doesn't generate a number, your output validation will fail. If your output validation fails, what will you do? You will again do another LLM call. So you are wasting a lot of LLM calls like this. Okay. That is why you have to do both. You have to do a constraint decoding which one way of doing that is Logits processor. Okay. Another way of doing that is using this tool calls API to OpenAI. Okay. And we have seen the pluses and the minuses of that. Okay. But after you have done the generation, you can check the completeness anyway using output validation. And if the output is not complete, you can go back and again do the generation. Okay, I hope this is clear.
One follow-up, this if you go back to this, yes, a list of colors where it generated 100 on the first step with Logit's processor. Just understanding, did we ask Logit's processor to generate a number while passing it? And for the second time, we also wanted a number, but as Logit's processor was not passed, it gave a list of colors. Is that correct?
Yes, yes. So this is an extreme case. Obviously, list of colors prompt is not correct, as you can understand, right? This is just to demonstrate the situation. So answer to first question is yes, you can see here in the first call, this is the first call, right? So what we did is we asked it log its mask, okay, with allowed token IDs. And what were the allowed token IDs? Allowed token IDs were for every token generated from this list. So we asked it to generate a list of numbers, right?
And is it this is Logit's processor reliable each and every time we run it for multiple iterations? Because coming back to that MCQ where the correct option was option 3 as per you, is not the output follows the input grammarly completely, is not enforced, right?
No. Okay, so it is enforced completely to a prefix, like I mentioned, right? So, for example, suppose I want to generate a phone number, okay? At every decoding stage, it will make sure that a number is generated, okay? So, this is there. But suppose after this end of sentence token is generated, okay? It will still validate this and send it. So, the complete phone number is not there.
No, but what if I kind of develop it in a way to do it completely? Will that work? I'm
How
just
will it-
asking.
It will not, right? Because see, what will you do? You will, at every time step, you will do a mask of tokens, right? Every time step, okay? And then, um, okay, yeah. So, yeah. So that's the point. See, so. So then what you have to do is maybe you can ask it not to generate the end of sentence token till the length of the generation is 10 or something like that. But there are many cases. So the short answer is that it might be possible, but it is complicated to ensure completeness of a grammar using Logits processor.
But it's still possible. If it's still possible, then the option 3 is incorrect, right?
Yeah. Okay. Yeah. So I guess the question is, it is not enforced by the Logit processor, right? So the Logits processor itself does not enforce a grammar completion. Let me put it that way. The Logits processor is only modifying the token probabilities at the per decoding step. But I get what you're saying. I mean, yeah.
Sorry. Yeah, it's okay. And the last follow-up question is on the JSON schema. Let's say if I'm asking LLM to generate a JSON schema with 10 key value pairs, among which 2 of them have another nested JSON schema. How do I enforce the output to always give a correct JSON schema? Because I'm asking it from a practical point of view that I've noticed when I do run that JSON schema for multiple iterations out of, let's say, 100, 90 of them run correctly, but 10 of them doesn't give the correct JSON schema. And when parsing it in future, it fails.
Yeah, so you have to do output validation, obviously. Um, uh, I have to, yeah, this is, yeah. So you do output validation and only 90, let's say if you are generating 100 and you are getting 90 valid JSON schema, you only use those, right?
Is there a way to generate correct JSON schema 100% of the time?
Currently, there are packages, like there is one, this, there's this package, but okay, I have to go, so it's not as, let's say there is no very standard or well-known way of doing it. Let me put it this way. Okay. There
Okay.
are some
But it would be
packages
helpful if you can help
do
me with that.
DFFS decoding. Yeah, I think it's called options. There is one package, I forget the name. Yeah, it is trying to do something like that, but I haven't seen many people use that. So it's not clear. It's an experimental thing.
Sure, if you could help me with this by the next class, I'll be grateful. It will help me in my projects as well.
No, that unfortunately will not be part of the syllabus, but yeah, maybe we can send, yeah, we can take this offline. Huh?
Sure. That will be helpful. Thank you, Professor.
Okay, next question. Let me just unshare. Yeah. Okay. Please explain the logit mask in more detail and where it is used practically. Okay. So that will take a long time again. I request you. So basically, see what it is doing. It is generating certain certain types of outputs preferentially, right? That is what the logit mask is doing. It's a constraint decoding. So you have certain rules, okay? Example JSON, example regular expression, example phone numbers, example date, example, so many things you can have. For each of these, you can have a schema, okay? And then based on that schema, you can have a constraint decoding technique which will generate and preferentially, like it can also you can also alter the distribution over the strings that it will generate, which will follow this particular grammar, right? This particular schema, right? And please go back and look at the code, and maybe if you don't understand a particular thing, it will be easier for me to explain, because I will just be repeating the same thing and it's like
Professor, one question in this one. So whether logit mask is compulsory to be used, or without that we can live with it in LLM and using it like for Gen AI or agentic AI? Is it
yeah,
compulsory?
obviously you don't need to use, if you are happy with unconstrained decoding, right? In most applications, people use unconstrained decoding.
Oh, it's good to have. It's not compulsory. Everyone has to use it.
No, not at all. It is only if you, let's say, want to generate particular formatted output, then you use it.
Okay. Thanks, Professor. Or one more last query. Means where it is preferably we should use it. Means just in a layman word, if you can tell us where we should use compulsory this logit mask and all.
Okay, a very simple example, right? So suppose you are running a food delivery website, okay? And in that website, the person has said in words, I want one order of this particular thing, okay? A particular food item. Let's say one roti, one dal, or something like that, okay? Now, you want a LLM application that will actually create a database entry directly and put it into your order database, and then you can serve that order. This application is clear?
Yes, yes, it is
Huh.
clear.
So what should be there in that order database? It should have like maybe the name of the person who has placed the order, the phone number of the person who has placed the order, the name of the item, the quantity of the item, and so on and so forth. So this is best represented as a structured JSON. You agree?
Yes.
Huh? So
Yes, yes.
then your LLM must generate a structured JSON, no?
Okay, means confined data means we have
But
to
the
use for
user will say,
searching.
the user will tell in words that, okay, give me one dal and one roti. Huh?
Yeah.
He will just write it, right? Now you have to, your application, your LLM based application must create this database entry. The database entry should be structured.
Yeah. Yeah. Thanks,
Yeah.
Professor. Thanks a lot.
Yeah, next question, please. Oh, what is a regex processor? It's a regular expression processor. So in computer science, we have this this idea of regular expression. Maybe right now may not be a good time to discuss that. Basically, you can specify like a regular language using slightly more than a regular language, but yeah, you can. Yeah, so there is this concept of regular languages and this thing. So actually, you can just read it up. Like it's a very common thing in programming. Okay, regular expression.
And Professor,
Yeah.
one more question. Like, what is regex pattern then? The processor is a one thing, and what is pattern?
So I will just tell very briefly. Man, this is. Let me just. Oh, I don't have the. Okay. So let me just. Can I share? Okay. Okay, so let me just do this. So okay. So let us say I write a regular expression, something like let's say word and then 126 plus. Okay, and then I say dot com. I'm just saying this. Okay, so this is called a regex pattern. Okay, this is a string, this is a regex pattern. What this means is that I think I don't need to have this plus. This means that there should be between 1 to 6 word characters. Okay, so for example, A, B, C, D, E, F .com. This will match this. Okay, so any string, so you can give it a string like S1. Okay, this string will match this regular expression. But if I give more than 6 characters, let's say A, B, C, D, E, F, G.com, this will not match this. Okay, so there is a way you can basically define, you can say, a class of strings which match a regular expression pattern. Clear?
Yeah, thanks.
Okay. Yeah, this is okay. Keep and stop the sharing. Okay, yeah, so this is, we can try to run the code, but we don't want to waste the time in one of these regular sessions. So what we are going to do, one of the doubt clearing sessions, we are going to have some of the TAs who will actually run the code. So there will be hands-on sessions which will be there, okay? So we will do that. But before that, please try to also run yourself. So what we are doing is we are explaining the code, and obviously the recorded video is also provided to you. Go back and listen to the portions that you are not understanding, and also the code is provided to you. For the current session, it will be provided. Try and execute that code by yourself. Okay. Yeah. Of course, somebody else will run, and that will help. But I think the best way to do it is do it yourself. And then, if you are facing a particular problem in the in that hands-on session, you can just come and ask a question. Okay. Next question. How does this statement make tokens negative and impacts while selecting the tokens? See, as I told, this score is the logit score. Okay, so when you compute the probability, you do softmax of that, which is e to the power the score by temperature by summation of e to the power that. So if you add a -10 to the logit score, what it basically says is you are multiplying the score by e to the power -10. This is clear. Okay. If you do that, basically, as you can understand, the probability of that decreases a lot. That is why you set it to -10. So you basically, when you are doing masking, you say for every token, the probability of generation is very low. Okay. And then you unmask the allowed tokens. So you make their probability, if you remember, their mask, you make it 0.
Sir, follow-up question on this one.
Ah,
So the token is a number. So I'm not clear how, when identifying the token, how this negative multiplication impacts. Because each token will be representing some string or some character of it. So
yes, but
can
you
you
are
please
not,
explain?
okay, so you are not subtracting 10 from the token. You are subtracting 10 from the mask of that token. So if you see, the scores is an array, okay, over all the tokens, right? And mask is also an array over all the tokens. It's a list.
Okay, so
You are
that
not,
means
you are not changing the token ID. You are changing the score of that token.
okay, so decreasing the score for all the tokens.
Yes, yes.
Okay. Okay, sir.
Next question, please. Okay. Yeah, maybe if you have a specific question, otherwise, because we have done some explanation, maybe, yeah. Is there a specific question? Okay. Okay, so then we will go. Uh, should we go? I think it will be difficult to start the next topic at this time. Maybe we can take some open question answering, and we will do the evaluation anyway in the next class.
Sure, sir. Let me unmute some participants. Alok Srivastav, you are unmuted. Please go ahead and ask your question. Alok Srivastav.
Am I audible, Professor?
Himanshu Upadhyay.
Yeah, am I audible?
Yes, yes, I can hear you.
Hello, Professor. So I had a question that there was a quiz in which you explained that logic processor doesn't understand completeness. I mean, there is a limitation on completeness. So this is one part that's not clear to me. Can you please explain that? Why is it not complete?
Yeah, so like I said, the way that logic processor works is it creates a hook which is applied in every decoding step. So in every decoding step, it controls the tokens which will be generated. It does not see the future, right? So it does not know the completeness. So for example, consider this, right? So you are generating www.google.com, okay? At every, let's say every character is being generated one at a time. Clear?
Yes.
Okay. So when it has seen GOOG, okay, it will say that whatever is being generated is a valid thing,
That is,
right?
yeah.
Now after that, let's say the LLM stops generating. It generates the end of sentence token and stops generating. Then it has actually not generated a google.com thing. It has not reached the end state of the generation process. Whatever it has generated till now is correct.
Yeah. Yeah.
Okay. But it has not ended. So it has not completed that. That thing the logic processor cannot by itself enforce.
Okay, I understood. Thank you.
Suman Naskar, you are unmuted. Please go ahead and ask your question. Abhishek Gupta. Abhishek Gupta. Akshay Sharma.
Sure. Hi, Professor. So, Professor, just wanted to be like today's topic, like how to run LLMs. I had like a couple of questions that came up to me. When should we use unconstrained prompting, tool calling with the pydantic or instructor, and custom logics processes based constraint decoding for the structured output? Let me reiterate. When should we use the unconstrained prompting, tool calling with the pydantic instructor or customs based constraint decoding for the structured outputs?
Okay. Yeah. So you want a summary kind of answer, right?
Yeah.
So what I would say is that if your application is such that you have to generate structured object, okay, many agentic applications you have to generate a structured object. Okay. Then, so by default, you should do a normal prompting. That is the normal, I mean, if I were to put a number, I would say at least 80% of the applications, you can just go ahead with the normal prompting. Okay. So the
Yes.
question is, when do you go to this structured output generation and then output validation? Okay. Suppose your output is being fed into a database. Okay. Or let's say your output, let's say you have an agentic system where your output is actually consumed by a tool calling. See, nowadays there are many agents, let's say these desktop agents and all these kind of agents, which will, let's say, so they want an LLM to do the planning for you. Okay, so let's say the very example that we always use is, let's say you want to plan a trip for yourself. Okay, you want a personal assistant agent running on your desktop that will plan a trip for yourself. Okay, and so there are certain stages of planning a trip. You want to maybe first find a place to go. You want to find a hotel. You want to find a, let's say, flight tickets. Let's say these are the three things you want to do. Okay. Now, you tell a LLM that your prompt can be something like, plan a trip for me to a place where it is cold, maybe somewhere in the hills. Okay. Maybe which is not too expensive. Okay. And book a hotel for 2 people and book also flight tickets from my current city. You mention the name of the city to there. Okay. So then what will this agentic system do? It will first do a planning. Okay. It will generate like a list of places. Then it will choose a place. It will probably query like external service, let's say a hotel booking service, to see which of these places has a hotel. Okay. And flight tickets. And based on all this, it will choose a place and it will book a hotel and do the flight ticket booking. Okay. After this, it has to actually do the hotel booking. For that, let's say it has to operate a browser or something like this. At that point in time, it exactly needs the ID of the hotel, the exact type of the room, the exact dates. So while the planning can be done in natural language, this thing has to be done in this tool that it is going to call. Let's say it's a browser that it is going to call for doing the actual hotel booking. Okay, that has to be a structured output.
So, Professor, just to summarize what you're saying is like the one which we are designed, like unconstrained prompting when output is only for human reading, and use tool calling with pidemic or instruction when output is consumed by software like database or another tool. Use custom logics based constraint decoding only when we have a strict token limit formation. Is my understanding that way it is? Like, just to summarize on the point.
I think constraint decoding anyway you should do, because you don't want to waste tokens anyway. So it's not a question of strict token limits. It's like if you don't use constraint decoding, then you might end up wasting a lot of tokens. That can be really, I mean, it can make your system not work at all, basically.
So, thank you, Professor. But in real applications, is the biggest failure risk usually is wrong responsing or wrong structure extraction or tool extraction failure? How should we prioritize safeguarding across these three? Like wrong responsing, wrong structure extraction, or tool execution failure? Like mainly as a product manager perspective when we are actually assessing the priority of safeguarding.
Yeah, that is, I cannot say, I mean, I'm just saying that these are different applications, right? Each of these you should try to make it perfect, right? When you are doing structured decoding, that should be perfected. And there are 2 steps to that. When you are doing planning in, or there are so many activities you can do without constraint decoding, right? Like you can do, like I mentioned, like you can do summarization, you can do planning, you can do question answering, you can do so many things which does not require constraint decoding. For that, you optimize the prompt that way. There are so many methods, right? So each aspect of the workflow should be optimized.
Understood, Professor. So the key idea is to use constraints only at the stage where output must be what we are actually looking into action oriented, while
Yeah.
keeping the early responses and planning stages.
Yeah.
Thank you, Professor.
Siddesh, you are unmuted. Please ask your question.
Hi, Professor. Just I wanted to check you actually while explaining the logics, right? We are making the minus infinite to the odd tokenized numbers, right? So let's say is that when we are doing that one might be in the output, there might be chances to missing the context, right, while getting the output from the LLM.
Missing the context. How? Why would you miss?
Because let's say example, when you were masking the odd number, let's say 0 and 2 and only even number, you are able to getting the values from there, right? So let's say the nearest
That is in
word
the
might be the
future, not in the context. Context is what context has already been generated. So that you are not changing, right?
But the token, the value of the token one means inside the what is the value, it is inside the token itself, right, for that specific database.
No, context is not changed. Context is already there. It has been generated. That is not changed. The future tokens is where, so the tokens that you are going to generate, the masking is applied over there. Now the rules for evaluating the masking, they will involve the context, but that is only for the rules. The score is only for the current token that you are generating. Am I making sense?
No, actually, I have one more doubt here. Let's say masking means exactly you were just hiding the tokens, or what exactly here in the logic masking?
Let's say you have some 2 million possible tokens that can be generated at every point in time.
Okay.
You alter the probability distribution over those so that certain tokens are preferentially generated. That is masking.
Okay. And I have one more in the real time scenarios, because you whatever you explained logic masking and instructor pandemic. So usually in the real time, whichever the most good fitting for the real time scenarios, because they have own pros and cons each logic masking and instructor and pandemic. But usually when we go for the real time, which one is best choose for use to reduce these things?
No, yeah, so this adds a step, but if your call function is not too heavy, I think it will be real time, and it will, yeah. So it depends on how heavy you are making your call function. Like we were discussing, if you are making a lot of, like you are using a lot of third-party libraries which are taking a lot of time to execute, because that call function will be called every decoding step.
Okay. And Professor, I have one more feedback. Actually, when I am following, so your explanation slides is I'm able to follow, but when we are looking for the real time, we might be not able to understand the things, because you actually Hugging Face, I installed the Hugging Face. So when you were explaining, I tried, but I couldn't able to understand what exactly I need to do in the Hugging Face. So these are all might be the things we are not able to follow up. Even though if you explanation is give, we may not able to give the explanation in detail when we are facing the real time questions in the interview.
So like we discussed in the session, like in the doubt clearing session, anyway there will be one hands-on session. Okay. What they will do is they will run the program. They will show you the program. They will run the program, and after every step, how it is running, what is happening, they will print and show you. That might help. If you are, in the meantime, if you are able to figure out maybe simple things like how to run Hugging Face, you can figure out, or you can ask in the chat group, the TAs may be able to answer. Okay.
Actually, my request is even we don't need end to end. At least if you are showing us to how to start, it will be good. Because even when we are not able to start itself, it is very difficult to do the R&D on basis of what you are explaining. So at least if you show the start, it is useful for us to at least we can sit and work on our on from ourselves. This is my request from my end on the off.
Where you are actually failing exactly? Can you tell?
Example, you actually.
So you are familiar with Python or not familiar?
I'm not fully familiar. Actually, I'm actually working on it. But usually, when you say actually last time I worked on Hugging models and I taken some data, I am just doing R&D on these things. So, but today actually when it came the Hugging Faces, I got to know the one where I can able to apply. But I don't know how I need to apply.
You should probably spend some time doing doing some Python. If you are not able to, for example, if you are not able to, let's say, do pip install, these things, if you are not able to understand.
No, I worked, Professor, for 3 years. I worked on Python, but exactly what I am trying to asking you when it is coming to what is the input, what we need to
exactly
goal of that, what we need to the goal. That goal, if you set, we can able to work on it. Even we don't know why we are exactly doing this. What is the goal of that? We don't know. That is my honest answer for this.
But you said you are stuck with not installing Python.
No, I didn't say that one. I am familiar with, not fully familiar with Python, but now I am already working on the Python. But like example, now we've explained the instructor, so I just know the overview. But if you give couple of examples where we can able to apply, if you give some exercise, it will be good for us to do from ourselves. Along with the slides, if you give some couple of real time examples, so we can work on that one. Because if you just show the way, then we can able to find ourselves. Actually, we are just not able to even focus on what exactly we need to do when you are explaining the things.
Okay, we'll see. I'm not exactly sure. Maybe we can. You can ask a exact question that will be more helpful. Like exactly what you don't understand. That will be helpful.
No, Professor, actually, whatever you were explaining in the slides, I am able to following up. I'm not complaining about the explanation. I am asking about when you were giving, at least let's say now your logic digits, logic masking you explained, and instruction where we need to. So if you along with that one, if you able to give some real time example.
Your suggestion is taken. Your suggestion is well taken, but that is always valid actually. What suggestion you are giving, that is.
Thank you, Professor. Thank you. That is what we are expecting, because it will be helpful for us to sit ourselves. We can work on that one.
Okay, so let us just go through this session, see if that helps. Because if you are, so what, instead of asking question, you are giving suggestion to me, which is fine. Only thing is that I don't know like what your exact problem is.
Exact problem, Professor. I am not even when I am sitting for the working, I don't know where I need to start, what I need to start. That is what I'm facing the issue.
Code is being shared. You start with the code.
But actually, along with that code, my request is if we are giving some real-time challenges, so we can work on that one. That is my ask.
Okay, so you want some exercise, but that is already being shared.
Exactly.
It has been shared. You have done that.
The assessment.
There are many. There is assessment. There is hands-on for the previous session, all of this has been shared. Have you done those?
Yeah, yes, Professor. I am actually whatever the code you have provided, I am actually
Then it
running
is
in the
good.
Google Chrome.
Then it is good. Then what is your problem? On this also, exercises will be shared. You can do those exercises. If you are able to do those exercises, then you are up to the mark. What is the problem?
Thank you, Professor. Last request is while explaining, if you are able to give the real-time scenarios, it would help us to remember the things when we are facing the interview questions.
Okay, okay.
Thank you, Professor.
Okay, thank you.
Thank you, sir. Like we can close the discussion segment here.
Okay, okay, okay. Thank you, everyone. Thank you. Bye. I should.